Today's date is the 16th of April, 2026. The time now is 10:17 p.m. So I'm gonna have to express this properly. So, properly. So what am I saying? That's no good. Uh, so expressing um, that, yes. So this video is gonna be on my work. Where's my paperwork? Is it there? Yes, it is. So we're gonna have the NSIGII drone. Oh, the work. Yeah, sorry about this, guys. So we're gonna have the NSIGII return drone. We're gonna have the NSIGII Sparse drone. So everything's gonna be a module from for Benedict. I'm trying to picture. We're gonna have a quadcopter, but it's like a drone copter. So for landing up and down. So let me just get to it. So NSIGI spelled N for November, S for Sarah, I for India, G for gold, um, I for India is a human rights protocol. It gives you food, water, and shelter. We got the NSIGI robots, humanoid robots, but the NSIGI is a drone. So NSIGI is a drone aircraft for humanitarian aid. For humanitarian aid, aid. So this is a drone that actually can double as an aircraft to carry food, water, and shelter. Food, water, and shelter. Uh, for food and water, uh, medical supplies, medication, treatment, for kind of a civil collapse, the kind of wars kind of environment. It is not a toy. It is never a toy. It is never a weapon, and it's never a weapon, and it's never a problem. It's never a problem. These are the three clauses of NSIGI. It's like what is bound by because it's a human protocol. It's never problematic. It's never problematic. It's never a toy, and it's never a weapon. And I'm trying to draw the diagrams today to express this kind of thing in kind of almost tense. This pen is rubbish, by the way. I have to add water to it. Problem. The never toy is an SD sub. It's a trilateral SDK. That means there's three SDK. It means there are three consensual SDKs. So the first SDK is called never toy, and basically for human in the loop. Human in the loop. So you get human in the loop. Human in the loop is never a problem. Never a problem. Human out the loop. Human out the loop is out the loop of the process of the operation. Human out the loop is never a weapon. Oh, the, so you gotta get human in loop. So you get human on the loop. That's never a problem. Human in the loop. No, no, human in the loop. Human in the loop never a problem. Human out the loop. Never a weapon. And human on the loop. On the loop is never a toy. That means and basically a model of verification via physics. Physical physics like spring physics or things that elastic, things that can verify twice, like an echo chamber. But you hear messages twice, you verify with consent because you receive verification twice. And Sigi is a human physical. This is basically bound to the ontological Bayesian intelligence infrastructure, intelligence OBI AI architecture and infrastructure as a simple AI systems using top-down and bottom-up reasoning. Top-down reasoning, or what I call imperative reasoning, or bottom-up reasoning, which I call declarative reasoning. So without further ado, let's get started. Let's get to drawing. So here's my board, my paper. Let me start drawing. So I'm gonna try to get the units correct here. So I'm gonna use my protector here. Put it here. I'm gonna draw the turbines first. So the turbines will be here. hmm So 4 centimeters. And here, should I? So the first I'm going to draw the turbines left. How the drone gets left. The drone has two lift modes. Two lift modes. Let me draw the first lift mode. So I'm going to draw it here. Should have a wing here. So this is centered. So my focus is here. Let me copy this. So the center here. I'm just going to center by the way. I know that this is 15. 15 plus 15 plus 5.5. 15 plus 5 is 15 plus 5 is 20 centimeters. 15 plus 5 is 20. 15 centimeters. I'll take 18. So I'll do bound by 15. 18. 15. Oh no, 10. 18. And 18 here is okay, 15, this is 15, 15, 18. You're gonna have a track, you're gonna have a circle here. Yeah. I'm just gonna replace this line with a pen marking on. It's not good to have a pen marking. Maybe just one here. 15 plus 12. 15. Let me just check it. 15 plus what? 15 plus 14. Let's just 15, 14. Let me get 14 plus 14 is 28. 28 divided by 2 is 12. 28 divided by 2. 28. 28 divided by 2. Calculate intelligence. Fixing to act on the jump. Yeah, try to compute basically capacity. Let me try to calculate this. Look at 14. Yeah, it's 14. 14 here. 14 here. Yeah, we get 14. So yeah, this one. 14 would be halfway. Uh, 9 plus 11. 9 plus 10. 9 plus 11 is 19. 19 divided by 19. 18. 18 divided by 2 is 6. 9. So we'll just put in 9. And on the drone here, we have a top-down plane. So we're gonna have a top-down elevation here. So this is a drone that can. This I'm trying to show you the wing. So I'm drawing the wing of the drone, and this is how the wing of the drone will look like. So the wing of the drone will look like as if you have a three drone, but it's a four drones in one. So basically, it's a four winged drone. So basically, the drone is gonna be four in one. We're gonna have four wings. Is it three wings? Four blades. Four turbines. So you're gonna have four propellers. Four propellers. Four propellers to propel the drone upward. You're gonna have four propellers. And you're gonna have. Let's make it five. No, it's gonna add more weight. Yeah, four propellers. So let me start off with this. You're gonna have this here. You're gonna do this now, dude. So this is basically propeller here. Let's do this way. So you're gonna get nine. So obviously this sensor is calculated as to the fourth part of 25 by 2, which is 14, 14, 14 divided by 14, 9, 4, 0, 0. 0, 0, 14, 9. I can have a countdown. You can have 0, 0, 14, 9. You can have something relative here, which will basically be here. You can have 1, 2, 3. 1, 2, 3. Should I do it that way? The one more white construct. I'll do 1, 2, 3. Yes, that's good. Well, I'll close it here. 1, 2, 1, 2, 3. Yeah, that doesn't matter. You're gonna have 14, 9, 14, 9. You're gonna have here padding. Gonna basically be alright. So basically, it's gonna be yeah, like just yeah. And for even here, you're gonna have the ratio. Yeah, so let's do 1 centimeter equals 1. I don't know. This is gonna use, but I'm gonna use it as 5 centimeters long. No, 5. Let's make it 2.5. No. So basically, this is what it looks like. So 2.5 centimeters long. So basically, you're gonna have three wings, and the three wings are gonna be like a four wings. So you're gonna have three wings spin as four wings, and you're gonna be a tricopter. And by your tricopter, you're gonna have one artificial wing, so one pseudo wing. And basically, the goal is to have a kind of takeoff procedure. So let me try and design it properly. Around my human rights. So you're gonna have three main wings, and these three wings act in air to make one big wing that can stand in the air at a certain altitude. So basically, if I go 6 centimeters here or 8 centimeters here, 6 centimeters here, that's 0. Do 3 centimeters here, and we double this one. 8 centimeters. 6 centimeters here. Yeah, 3 centimeters of origin will be here. Yeah. On this channel. Now, what angle is this? I don't know what angle it is now. This will be 6 centimeters and an angle of, let's make it 30 centimeters, 30 across. That's 14. Angle of 14. So this needs to be the same thing. Angle of 14. Angle of 40 is here. So 6 centimeters across will be here. And this is basically 6 centimeters downwards. The angle of 0. You're going to have a tricopter there. And you're going to have a wingspan of 3 centimeters. So just the whole 3. You're going to have I now have a compass or no, access to have to improvise here. Then we'll do uh, uh, 3 centimeters, 3 centimeters this way. Uh, 3 by 2 centimeters. But that means they're not even. Wow, that means they're not even. Are they meant to be even? I don't know. Whether they're even normally. 3 by 2 centimeters. No, they cannot be even. Yeah, that's the kind of magic law sign. 3 by 2. You're gonna have um, colors would be 3. Right. So, yeah, 02. No, I should have think about an angle here. So this is 3 by 2. The 2, but these are not taken off, so this will be fan. This new move fan, so we're gonna have 2. Let's make it 3 by 3. No, I didn't dissect it very well. I have dissected basically these geometries. So basically, you're gonna have 3 wings. 1. I don't even know. I can't do this. So center. This is 90 degrees. So basically, I have to rotate this. Like yeah. It will be west. So the spacing will be. Let's say you have a center here. Centers here. You have there. You have. So you're gonna have down here. You're gonna have the spacing of 30. Be 40. Spacing of 40. Be to the 5. So it's 20. So basically, this is 3 centimeters. This is 3 by 2 centimeters. 3 centimeters. 3 by 2. But this is basically an arc of 30 centimeters. I don't even know. Basically, this is the 30 centimeters. Really. Yeah, 0 centimeters. Yeah, 3 centimeters. Uh, Let me draw something that make it using one. No, 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 no. Someone's playing my computer. No, no, no Asper. I just no Asper. No Asper. Well, this is here. Uh, this thing is, oh, this should be on two. This should be on three. Okay, this should be this one three. So this would be in two. Depends on the way. This should be three. Oh, why is that? Three. Three blades on the four. Uh, yeah, three. 60. So, not 60. 60. Yeah. 90, 90 degrees. Mm. So that's what I did. So uh, I'm still doing the work, but it's gonna take long. So let me try to stop auto AI from doing the work. Let me try to stop auto AI. So what I'm saying is that we're gonna have three wings, three propellers, and three propellers gonna have propellers, three propellers are gonna be spinning. We're gonna have one artificial propeller. So you're gonna have one fake propeller, but this basically is gonna be basically gonna assemble into one propeller in the air. So propellers, propellers. So you're gonna have a turbine. And you're gonna have a propeller. So how do propellers work? So you're gonna use the take lifts. The propellers are what you're gonna have. So you have three propellers in one, but you're gonna be as one propeller. So you're gonna have actual one propeller too. And when you get to certain altitude, you're gonna have actual one propeller. So if you want to move something forward, you need to push backwards. That's what I'm gonna say. Describe Sir Newton still holds true to them. Newton's theory of motion, something called action and reaction. It's not always obvious, but in essence, we need to move forward or suffer around the dust. In a car, the wheels do something. The tires kick against the road. That's what the ship and the planes have the propellers. So you can have three propellers, you can step into one propeller, and that's the goal of the whole system. Uh, uh, so basically, I've drawn my propeller here. I've made so much mistakes. So I'm gonna rub it out and do it again. So basically, I'm gonna draw a propeller here. Uh, 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 show you the cover to the draw. I'm gonna draw three propellers over here. Wait, a propeller here to my 2 centimeter, 3 centimeter propeller. No, 2 centimeter propeller. I'm gonna be gonna have a space of 90 degrees angle. So you're gonna have 90 degrees here. So here you're gonna have a propeller 3 centimeters. You're gonna have an angle of 30 degrees. 30 divided by 360. 360 divided by 30 will give me 1.5 propellers. So you're gonna have one uh, and a half of the ratio. So to cover 360. So one half ratio will be uh, 36, no, 360 divided by 30. This is 12. So you can have an angle of 12 degrees. No, 12 degrees. If I have 12 propellers, if I have a degree of 30 degrees, so if I make it 30, I have to do, so let me make it 360 divided by 45. Let's see what it gives me. 8. So 8 propellers. Let me make it 4. 4. 360 divided by 8. If there are 8 propellers, there'll be 45-degree angle. So let me make it 360 divided by 10 times 8 divided by 8 to be 2.8. So let's make it 360 divided by 8. 360 divided by 8 to give me 45 degrees. So 5 degrees angle is what I need. So I start the point here. I make it 45-degree angle, which would be here, here, here. And I go and draw a line from here. Uh, is it 3 centimeters? Or make it equidistant. So we're gonna have 3 centimeters, 4 centimeters, 5 centimeters. Gonna have this one here. 3 centimeters. You can have 3 by 3 centimeters. 3 by 3 centimeters. 3 by 3 centimeters. Hold on. 3 by 3 centimeters. This is you can have one of the degrees. You can have from here. You can have another 45 degree position. We have 45 degrees will be yeah. You can have 3 degrees. Yeah, 45 degrees here. So 45 degrees will be yeah. You're gonna have 45 3 centimeters here and 3 centimeters here. This is about eight. Eight. This is about eight. Will give me 45. Oh, 360 divided by eight will give me 45. So 45 degrees will be here. So let me try to measure this one. So how much do I do? I want four propellers? Yeah, I want four propellers here, so I can have the maximum lift. So yeah, I'm gonna have four. Yeah. Where's my racer now? Where's my let's run so we're gonna have the rotation, we're gonna have rotation for 5 degrees angle. So basically I will see this one for 5 degrees here. So for 5 degrees here will give me yeah. Because for 5 degrees gonna have uh another for 5 degrees also. For 5 degrees. Yeah. What? You're gonna properly. No, I'm good. So I'm trying to propel this into the sky. Trying to have a battery. So, this is very big on Claire. Very unclear to many of me. But, let me try and do it right now. Someone is 3 centimeters, 4 centimeters, 3 centimeters here. Three- Yeah. So basically, like propellers here. So you can have one propeller here, but this one propeller uh, that is repeated 3 times. So I'll do it 3 more times and show the shape of the drone. So you're gonna have the drone here. So basically, you're gonna have basically I'm under the drone. Basically, I'm redrawing the drone to show you how it looks like. Basically, the three propellers are at an angle to each other, and they are basically at 365 by degree. 360 divided by 3 is 20, 20 degrees. So 20 degrees. So basically, I have to start 20 degrees. So they are 360 drones. They are 300. Basically, they are the degrees of the drones are. So you have a basically the drone's gonna be propellers that are facing upwards, and basically they're gonna act as one propeller. So basically, yeah, it's like your toe, it's like your toe. So your toe has like a spare. You have a toe in between your toe because that is for grappling. So your toe. Think of your feet as think of your feet as a toe. Your feet has toes in it, and the toes are in the air. No, basically you swing it to your monkey, and the monkey has a skeleton. So you have a gap in between your toe, and there's a toe, extra toe, because those toes have to grab the space. They give space to grab yourself. There's space to grab. You follow the tree. So the same thing with the sky. So you have three propellers, but then join together into one propeller, and that propeller is gonna be one big propeller that you can move around. Basically, you can use to stop to be stable in the sky. The same concept applies. You're gonna have 6 centimeters. What angle is this? What angle is this, Namdi? You can use my rule on my angle here. I'm seeing is 45 degrees. It's 40 degrees. So 40 degrees, 40 degrees here. Gonna have this. So I'm gonna do the three. I'm gonna draw so this is what it looks like basically. So four propellers here. One, two, three, four. We're gonna have four more on this side of the paper here. So you're gonna have four more. You're gonna do four more. So they are the. Let me just draw it. 3 centimeter by 3 centimeter, and the angle is they have a space of 5 degrees. 5 degrees. So 5 degrees will be here, and that will be for 5 times 3. Gonna 3 centimeters there. Let me just go. Wait. Probably go here. So basically, you got two propellers here, and this second propeller here, and I'm doing it already. So basically, you're gonna have three propellers total. Basically, I'm designing robots too, but I have to see how it goes. I'm trying to do it properly. So you're gonna have three propellers. They come one propeller on the one wing. I don't know how to do this. Gonna have 45 degrees. Gonna have okay. Look, so basically, this video is past for 5 minutes, and I can't draw this past for 5 minutes. Can't go past 15 minutes. So three propellers are here. So I'll draw my video. Then three propellers. It's gonna act as one propeller. It's gonna be like as one propeller. It's gonna be one system, and it's gonna spin like basically it's gonna be spinning in the axis of 360, counterclockwise. So generally clockwise. Mm.